Still, I hope you had some nice coffee to get you refreshed. You might need it. We're going to make a rapid journey from dream to reality in just 45 minutes. So strap into your seats and give a warm welcome to Holly Cummins.
Thank you very much, everybody. So I've got a few revisions to the title. So the first is that it's called From Dream to Reality in an Hour. But the quick-witted among you will notice that we only have 50 minutes. So from dream to reality in 50 minutes. And those of you who are paying a lot of attention will know that actually it's probably more like 35, 40 minutes now. But I didn't do a slide for that. And you'll also notice that I am not projecting from this laptop, which is where my web browser, Eclipse, command line is. So the further revision to the title is From Dream to Shattered Dream in 30 minutes. But still, it's going to be awesome. Just set your expectations low. So let me tell you a bit about myself. My name's Holly Cummins. I work for IBM. I've been with IBM for about 15 years. I've done a whole bunch of things. But what I do at the moment is I'm a consultant in the Bluemix garage in London. And what we do in the Bluemix garage is we're a services organization, and we use lean startup, extreme programming, and Bluemix design thinking to get our clients really able to innovate at a speed that they didn't think they could innovate. So it's incredibly fun. And the thing that makes it possible as well is the Bluemix platform. Before I was there, I was the delivery lead for Websphere Liberty Profile. So how many of you have heard of Websphere Liberty? A couple of hands. I think one of the challenges we have with Websphere Liberty is just getting the message out, because it's actually an amazing server. It's so fast, it's so dynamic, it's so pleasant to use. It's really, really, obviously I have a bias, but it's such a good piece of engineering. So we'd love to see everybody aware of it, because we're so proud of what we did. So we really do love Liberty. I'm an Apache committer on the Apache Aries project. And if you'd like to know more about Apache Aries takes the best of OSGi and combines it with the best of Java EE. And I have written a book on the subject, so you can go knock yourselves out learning more. The last little bit about what I do is I really love coming to conferences and speaking, but my boss would kind of like to know why he should pay for me to do it. And I said, no, it's really good, but you can help me prove it to him by going to this URL and signing up for Bluemix, because it is really good. How many of you have heard of Bluemix? A couple of you. Bluemix is IBM's cloud offering. It's platform as a service, it's containers, it's hardware, it's the full stack. And what makes it, I think, quite different from anything else out there is that it's basically IBM as a service. So you can get Watson, you can get the Internet of Things, you can get all of this, and it's really easy to use. It's free to try. So please do help me prove a point to my boss and visit that URL. But I'm not here to talk about that. What I'm going to talk about is microservices. So how many of you would say that you're using a microservices architecture at the moment? About a quarter, I think. How many of you are thinking of it? About half, which does make me wonder what's up with the rest of you. So how many of you know that you don't want to use a microservices architecture, so you've come here to convince yourself that it's not right for you? OK. I'll come back to that at the end of the talk. So let me talk a bit about monolithic applications, because that's what we're used to. So monolithic application, we sometimes think of a monolith as not having any modularity, but of course it will have modularity. But that modularity is just internal to the application. And when we want to scale a monolithic application, what we have to do is we have to take that application with every single component in it, and we have to just copy it out and scale it out. Problems happen when something goes wrong in that application. Because instead of just one server or instance failing, usually what happens is that the same code is in all of them, and the same bad code will take out every single part of the system. So even though you've got it scaled out, if you've got a flaw in one module, that module will probably take out every single part of the system. So your failover and your redundancy isn't really buying you as much as you hoped it would. And that means basically your system is failed, which is not so good. In a larger organization, you get problems as well when you want to do an update, which of course you will. And ideally, you want to do an update lots and lots, every day, several times a day. So what happens when you do that? Well, because everything is packaged in one great big box, when you do the update, you have to update everything. And that means everyone's release cycles need to line up. And so if you're ready to go and you really want to get your fancy new user feature out, or even more importantly, your bug fix, that means that your neighbors down the hall also have to be ready to go because it's all going together. So that can be a problem. And to update, you can't just take out the bit that you've actually interested in changing. You have to take out the whole instance and bring back a new one. And you can roll that out. So it can be, you can still get the failover and that kind of thing. But it feels a bit clunky and a bit big. And if you want to make radical changes, then that becomes very difficult. Because no matter how much we try, you probably will get some bumpy patches along the way with a radical change. And if you've got a monolithic architecture, it has to be rolled out all at once. You can't just change one little bit of it, see how it works, get the feedback, and then cascade that across that pattern. It's all or nothing, really. So I have a demo, and all good internet demos involve cats, of course. Everyone knows this. So let me present to you my demo. I've given live demos before. So you may ask, why catastrophe? Because I've given live demos before. I know what happens in live demos. So I have my application here. And it really, really may be foilware at this stage. But I have a simple cat application, which has a whole bunch of services: an authorization service, a scoring service, a web front end. And I, in principle, have it living on this URL on... See, there's that laptop there, but it's not actually connected to anything. And there's a laptop up there which is projecting. But that laptop up there doesn't have this demo on it. So what I was going to show you, and you can see the slides are still here, is I was going to do some live coding to improve my demo. But the nature of live coding being what it is, it wasn't going to go very well. This is a really compelling demo so far, right? And I was going to introduce an out-of-memory error. And because of the nature of the system, because it's all together, my out-of-memory error in one little module takes down the whole system. And if I'm really unlucky, it takes down the whole laptop and the whole presentation. But we'll leave that aside. So if I break my system up into modules that are actually discrete instances, much more sandboxed, then it means I've made things, in some ways, a lot more idiot-proof. My out-of-memory error will just take out one. But in other respects, things have got more complicated, because now my modules can't just interact by Java calls. They have more complex interactions. But it does have an advantage, because it means when I want to scale my system, I only need to scale the bits that are actually under load pressure. So if I introduce a memory leak, for example, I only need to scale the bits that have the memory leak. I don't need to scale the whole application. And sometimes I think when we think of microservices, we think each bit is going to be on its own box. Well, in the era of containers, that's not necessarily true. And even before the era of containers, that wasn't necessarily true. So you could have multiple instances running on a single box, but they still do have some insulation from each other. And microservices make it much easier to evolve the system. So instead of having to change everything, you can just change one bit. But microservices do have their hazards. So based on those slides there, it sounds like really great, all advantages. You can scale it independently, you can do evolution, you have much more flexibility because you don't have to coordinate with your mates down the hall to figure out when you should do a deployment. But, microservices do put some extra demands on your organization. So this is a red book on microservices, which I do recommend. And I was reading it, and I saw this bit, and I thought, oh yes, this sounds familiar. Because microservices absolutely cause an explosion of moving parts. So where before you had one system, now you have a lot of systems, and you have to manage all of those systems. And the only way you can do that is if you're really good at managing systems. So this is what an explosion of moving parts looks like. And I think sometimes when we talk about microservices, we think of it as, I've got a Docker container, I've got a laptop, I've got a whole bunch of Docker containers. It's actually still just one machine. And what I wanted to do is I wanted to really make it concrete that when you make a system, a microservices system, you are spreading it across different systems, different boxes. And so to make that concrete, what I have is I have a whole bunch of literal moving parts. So probably only some of you can see these, but these are my Raspberry Pis running my catastrophe demo. And if I had a laptop, I could connect to them. So this is what it looks like from here. And I like to think of this as the data center in a handbag. So this is really putting the micro into microservices. Because one of the reasons to use microservices is that it means that each part of the system should be a lot more light in terms of its resource constraints. So you should be able to set up a little cluster like this and have it work. And then the counter is that with the microservices, you do have a lot of moving parts. So how many of you using microservices are using Docker? Good number of hands. Are any of you doing microservices without Docker? A couple of hands. I've sometimes had conversations with people, and after a while, and they're really interested in microservices, but after a while, it's become clear that they're not really interested in microservices. What they're really interested in is Docker. And Docker is great. We love Docker in IBM. But you shouldn't switch to a microservices architecture just as an excuse to use Docker. Because you can use Docker without microservices, and you can do microservices without Docker. So you need to think about your motivations for using microservices. And you need to think as well about some of the things that the stumbling blocks that you may encounter on the road. So these are very old, but they still apply today. How many of you have seen The Princess Bride? Only a couple of hands. The Princess Bride is a classic movie. It's one of my favorite movies. And there's a character who, when faced with mounting evidence, continues to say, inconceivable. And each time one of the other characters says, you keep saying that. I don't think it means what you think it means. So I think sometimes when we think about distributed computing, we think, oh, well, this could never go wrong. But actually, it could, and it does. So things like we think that the bandwidth is infinite. Well, of course it's not. We think that the remote endpoints are never going to fail. Well, of course they are. And when you switch to a microservices architecture, there is a lot of complexity that comes with it. So this is... I didn't stage this photo. This is actually what this demo looked like a while ago. And I couldn't actually find the computers because there were so many wires. And that was a physical thing. But the actual schematic of it ends up being the same, that you have a whole bunch of complexity that comes when you try and make these things talk to each other. And so really, in order to make any kind of sensible microservices, you need DevOps. You need 100% automation. I think that's the absolute most important thing, is don't even think about microservices unless you have 100% automation. So with my Raspberry Pis, by nature, I don't have 100% automation. And the closest thing I have is SD cards that I can swap in and out. But I don't recommend that as an automation technique. Really, you want 100% automation that doesn't involve any physical cards. So how do you get from where you are to a microservices architecture? Now, can anyone tell me what this says? There's someone over there. Yes. So the answer is how to break up your code base without breaking it. And you'll notice the quote is attributed to me, but it's in German, and I don't speak German, so clearly I did not say it. But I wrote an article for JAX London, and they translated it, and they added that headline as well, which I thought was very clever. So when you're moving, what you need to figure out is how you can take your existing system and break it up into pieces without breaking it. And fundamentally, if you've got a good modular starting point, that does become easier. So in this case, my application has 4 modules, and I can just put dividing lines. And you take the communication that was there, and you replace it with HTTP communication. And usually, that HTTP communication will be REST. We tend to think of microservices and REST as going together. It doesn't have to be. It could be some other messaging. So you could have messaging, but usually, realistically, it's going to be REST. So in my old monolithic architecture, when I wanted to expose a service in a really clean, modular way, what I did was I used CDI. In my new architecture, when I want to expose it, I use JAX RS. And the code actually doesn't end up being that different, which is kind of nice. And it especially doesn't end up being that different if I use JAX RS to automatically handle my JSON parsing. So I'm just, from the perspective of my code, I'm sending Java objects along the wire. From the perspective of everything on the wire, I'm sending JSON. But I don't have to know about it, and that does give me more flexibility. So I would put in big thumbs up for if you're doing REST and Java, do take full advantage of JAX RS. So in the old world, if I wanted to consume it cleanly, I'd use CDI, I'd use an @inject annotation. In the new world, it does end up, even with the magic of JAX RS, it does end up being a little bit more complex. I had to have all of that, but it could be worse. So now, the question is, does it actually work? Well, let's see. So we have the application down here. And I'm not going to attempt that, because I'm going to go directly to the cloud. Because there are days when you want Raspberry Pis, and then there are days when your computer doesn't even connect to the display, and then you want the cloud, really. So we have, luckily I've come prepared. So we have the cloud. Now this is going to be an adventure for all of us, but I hope that at some point this display might. Now, the reason I'm looking so very perplexed at the moment is this isn't my computer, and the keyboard is a different arrangement from mine, and I put hyphens in my URLs on the cloud, which seemed like a really good idea at the time, and I can't actually find them on the keyboard. Because I think you all know how live coding is, right? Basic tasks become difficult. So a hyphen. Ah, hooray, thank you. So I was looking for a slash, but no. OK. So hooray. So I think, aha, excellent. So this is my microservices application running on the cloud on Bluemix, which is a wonderful fallback for when things go wrong. So if I sign in, that lets it know who I am. And now you can see it pained me to do this slightly because it made it look a lot uglier than it did before. But I've put sections on so you can see what's coming from each bit. So I've got a cat service that gives cats, or in this case, Javamans. And then I've got a bunch of cats. I've got a leaderboard. And I've got an area where I can say, who is this cat? So I think this is Tom, of Tom and Jerry. So if I say, have I got the name right? Then what's obvious to me at this stage is that 2 of my microservices are actually missing. So the front end is there, but when I do a guess, I don't actually get a score, and I don't have a leaderboard. So I can do some live debugging, because that's always fun. And I can show you. So I can log into Bluemix. The @ sign. So what was it? In case I need it again. Okay, thank you. Now I have to hope I don't have any fancy characters in my password, or I'm really going to be in trouble. Oh, thank you. Perhaps we won't save the password. So you can see on my dashboard, I have a whole bunch of applications, and the leaderboard application is stopped. So let's start the application. And now, if we go back here, so what this is doing under the covers is it's spinning up a Cloud Foundry container for my application. It's starting up Liberty, and then it's starting up my application, and then it's assigning a route to it. And you can see I've got some services as well. So the leaderboard stores everything in a JPA database, and so it's got a service assigned to it. So if I now try and do the scoring. Haha, magic. So you can see that we now have a leaderboard. And if I go to the next application, I can say that this is Grumpy Cat. And there's a couple of things that are still not quite right, I think, because this should be showing the score as it comes in. But you can see as well that I've got a little scoring service, and no matter what score, or no matter how good my guess is, it gives me a score of 70%. So there's an opportunity here, and this is the sort of thing where microservices really work, where in my first pass, I did a pretty naive scoring algorithm. I mean, naive is actually probably a pretty generous way of describing something that returns 70, no matter what the input is. So that, you know, it would be better to at least do a case-insensitive match, and then if I wanted to be really fancy, I could do, you know, some sort of distance analysis. So we can go back to the slides. we can see that it sort of works. And one thing to note is when we looked at it in the Bluemix dashboard, I had just one database. But that's because only one of my services required a database. And so if I had more services that were using a database, it's really important to divide up the database as well. Otherwise, you have these services that are supposed to be decoupled and supposed to be able to evolve independently of each other, and yet they're completely tied together by this database coupling. So it feels sometimes, I think, a bit strange and painful to divide a database and have some, because that is probably going to involve some duplication of knowledge, if not of data, but it's important to do. So in this case, we've got multiple databases. So let's think a bit more about my network topology for both my in the cloud and my database in a handbag, or my data center in a handbag. When I first started setting this up, I had a problem because every single one of these Raspberry Pis had an IP address, and I didn't know what it was, which was a bit of a problem, because if I have microservices and I want to be able to route something to the right microservice, but I don't know what it's called, that's pretty hopeless. And you can resolve this by giving everything a static IP address, but then you still have a problem because each one of those servers is a Snowflake server. And if one of them goes down, it's difficult to replace it. So I think we all know Snowflakes are bad. With 100% DevOps, with 100% automation, with microservices, what you really need to be aiming for is disposability in your services. So, we saw in that case, my auth service had gone, I was going to say it had gone down, but actually what had happened is I'd stopped it 5 minutes before the talk. So in that case, what you need to be able to do is just click a button and have it come back up. You need to not have it be a traumatic event that a server goes down. So no Snowflakes, aim for disposability. Another advantage of aiming for this kind of disposability is that you really want to be able to scale as well. So if I have all of my IP addresses, but one of my services ends up getting quite a lot of load, and I want to route more traffic to it, if I have just a fixed IP address, then that means I can't do that. So I've got server Lovely, my Lovely server, which is getting a lot of traffic, and I bring in Lonely server, and it's got the same code running on it, but nothing's getting routed to it. So you really need some mechanism to allow you to do that kind of load balancing. And there's a lot of things that you can do. The simplest one is just that you're going to have a load balancing server, and then you're going to have some kind of dynamic DNS or a DNS that you control. And that will get you a lot of the way. But there's lots of other things you can do as well. Excuse me. Right. So you can use Kubernetes, very popular. You can use Apache Zookeeper and Curator. I think that was very much the thing to do a few years ago. I think that's slightly diminishing popularity. You can use Eureka, you can use etc.d, you can use Consul. All of these are pretty good options. And to some extent, what you choose is going to be determined by what platform you're on. So if you're using Docker, then Kubernetes is a really natural mate. If you're a real Java shop, then Apache Zookeeper is going to be attractive. If you're using AWS, then Eureka works really well there. It also works really well on SoftLayer. If you're using etc.d, well, that started with CoreOS. So if you're using CoreOS, maybe there's an affinity there. Consul, I really like Consul because Consul's really flexible. So it has a Java client. It has an HTTP interface, but it also has a DNS interface. So you can get the same behavior that you would get just with old school DNS, but with something that's much more powerful and configurable. There's also, it was announced about 4 days ago, in Bluemix, there's a service discovery offering now. And so I don't actually know the details of what it's using, but there's going to be Eureka support and Consul support coming soon. So then it's going to be a really kind of a one service discovery to rule them all, which should be quite cool. So going back to my catastrophe monolith, when it was a monolith, I only had a couple of projects. And when I converted it to be microservices, I ended up with a lot more projects. And what that's reflecting is the fact that to make that switch to microservices, you probably will end up having to invest in some plumbing to handle things like, I'd like to talk to this service, I'd like to discover it, but what happens if it's not there? What happens if the connection goes down? So the Netflix OSS, libraries were designed to support this kind of plumbing. There's other libraries out there. You do want to probably take advantage of some of the existing libraries instead of rolling your own, because rolling your own is expensive and the problem has been solved many times before. So in my case, what I did was I ended up using Consul. And what Consul allowed me to do is on each of these connections, as well as the REST endpoint, I have a little discovery step that says, I'd quite like to get to my authorization service. Where does my authorization service live? And the service discovery handles it. And that has a lot of advantages because it means that if things come and go, the system can respond. And with service discovery, one of the challenges that there is that often you have to, the service discovery will take care of providing a point to publish and allowing things to discover. But the actual registering still has to be done by hand and is pretty tedious. So because I'd come from Liberty, what I did, and I was very pleased with myself, is Liberty is extensible. So as well as the servers the features that come with it, you can write your own. And what I really wanted is I wanted something like, I could say, this server uses discovery. And then I would tell it where my Consul server was. And then without anything else happening, it would automatically publish my services. And then it would automatically unregister them when the server went down. So I thought, wouldn't this be nice? And I made it happen with, probably I could have just written the code to register the services about 20 times over instead of the code that it took me to do it in an automatic way. But I have never seen a problem where to do it in a lazy way at great expense didn't appeal. So this is what I've done, is I've got a little service that auto-publishes the endpoints, and then it hooks into the Liberty annotation scanning. So anytime it sees a REST annotation to publish an endpoint, it says, aha, let me publish that. And the lesson here, I think, was that Liberty extensibility is really cool. So if I just switch back to this screen now. Oops. And now I've got this running in a container on Bluemix. And so you can see that service there is representing Consul itself. And then all of the rest of these services are representing the application. And so if I stop one of these services, then I should see that it goes away, which is kind of cool. So I stopped the scoring service. It detected it was going away, and it frantically sent out a message to Consul saying, I'm going away, I'm going away. So, amazing. So if we switch back to the main slides now. Oops. If I use the right remote control, it helps a lot. So this is the service for the Consul discovery, if anybody's interested. We'll skip over the bits that involve talking to the local Raspberry Pis. And the backup plan is the cloud. And we've already done the backup plan because we're ahead of schedule. So, are we done? I think we are. So I think we've got time for questions. Thank you, everybody. I should say as well, if anybody would like to see the data center in a handbag, I'd be happy to show it to you, not projected, afterwards. Stunned silence. I think everybody's just afraid that if there's a question, it might involve a demo. And that. No questions? Awesome. Go early to lunch, everybody.
All right. Thanks a lot, Holly.